What's Timmy's secret? How do we determine these transformations? Remember that there are these special vectors, the unit basis vectors. This is the vector 1, 0. And we can look at how a transformation transforms the vector 1, 0. That's the arrow with the dashed lines. Similarly, we can look at the other unit basis vector in 2D. That's the vector 0, 1. And we can look at how it transforms. We know that we can move vectors anywhere we want. Okay, now, it turns out that how this square right here transforms determines completely how a linear transformation acts. Take any vector inside the square. You can decompose it into a vector in the direction of the first unit basis vector and one in the direction of the second unit basis vector. And you can see how those transform, and that then tells you exactly where the transformed blue vector should be. Similarly, if you have a vector outside the square, you can look at the component in the first direction and in the second direction, and that then tells you exactly where that vector needs to go. Now, let's have a look at Timmy. What we just noticed is we need to look at how the now let's look at Timmy. What we just learned is that we need to look at how the 1, 0 and the 0, 1 vectors transform. That will tell us how to fill in the entries in matrix A. Here's the first unit basis vector. Notice that it is transformed into this vector right here. But that's the vector 0, 1. So that should become the first column of matrix A. Similarly, this is the second unit basis vector. If you just look at the picture, you see it gets transformed into the vector -1, 0. And we know that that should become the second column of matrix A. This gives us a systematic way of determining what the transformation ought to be by looking carefully at Timmy and the target. We learn again, a linear transformation is completely defined by how it transforms the unit basis vectors.